Hello, everybody. Welcome to Chapter 15, Trace Minerals. After this lecture, we will be done with the uh, micronutrients. So by now, you've gotten used to the drill and what you need to know about all of these. So like the other vitamins and minerals, you really need to know important food sources, major functions, deficiency and toxicity of all the trace minerals that we're going to review in this lecture. Within the deficiencies and toxicities, can have a good understanding of who's at most risk, where do we tend to see these. With minerals, we're going to talk quite a bit about absorption. They can be difficult to absorb, and so we want to understand why that is. It's especially important if you're trying to treat a deficiency. And then we're going to end with thinking about all the different ways you can get your vitamins and minerals and different types of supplements. So just real briefly, an overview of trace minerals. Like major minerals, they are inorganic substances needed by body in small quantities. Trace minerals are found in very small quantities in the human body. That's why they're called trace. And today we're going to talk about iron, zinc, copper, manganese, iodine, selenium, chromium, and fluoride. There's a lot of reasons for this, but they're typically difficult to measure both in the body and in food, mostly because they're in such small amounts, and sometimes they can be bound to other things. Um, Sometimes they're found in more than one chemical form, so that is kind of a unique feature of trace minerals. So we're going to start with iron. This is probably one of the more famous minerals, probably because a lot of people happen to have a deficiency in it. If you're looking at the slide here, you can see I'm showing you two forms of iron, one from meat or animal products, especially red meat has a high concentration of iron, and we can also get iron from plant sources as well, although it doesn't tend to be as easy for the body to absorb. So we divide that plant versus animal. We talk about heme and non-heme. I always think of heme as hemoglobin, which is that protein in our blood. And so when you eat animal flesh, you are in fact getting that hemoglobin. That's part of their physiology, and myoglobin, which is the similar protein that's found in muscles. So just because it's similar to a human, I guess, physiologically, heme iron also tends to be easier for us to absorb. Non-heme iron is a form of iron that we find in vegetables, grains, and supplements. So needs vary. I have this highlighted in red because I don't usually ask you to kind of think about the RDAs, but iron is kind of unique, and I do want you to remember these. So for women, adult women actually have the highest iron needs of any other population group, although I will say a pregnant woman and a lactating woman needs slightly more. But women need more than men. Men actually only need 8 milligrams a day. And after menopause, women drop down to the same level as men. So if you kind of think about, well, why might that be? Why does an adult woman need 18, but an older woman only needs 8 and men only need 8? It's simply because women lose blood every month when they're menstruating. After they've gotten through menopause, they're not menstruating anymore, so they're not losing that blood. When you lose blood, you lose hemoglobin, and therefore you lose iron. So that's the physiological reasoning behind those numbers. And I mentioned this already, that iron is a very common mineral deficiency, both in the United States and worldwide. You can see iron right there as part of hemoglobin right there in the middle. Um, the absorption, transportation, and excretion of iron is actually fairly complex. There's a couple of different forms of iron. I don't usually go down to this level of detail, but I will for iron just because it is such a a common deficiency, and people tend to be interested in it. So the first protein we're going to talk about is ferritin. You can measure ferritin um, through a blood test. It's a special protein that binds iron that hangs out in your small intestine. And most people remember ferritin as the storage form in iron of iron. It's made in response to iron stores. So if you have a lot of iron, maybe you've been eating a lot of iron or you're taking iron supplements or both, you will have a lot of ferritin. If you don't have a lot of iron, your body won't make the ferritin. And what's cool about it is if you have a lot of iron and you make a lot of ferritin and your body is storing it, it actually acts as something called a mucosal block. So basically, when you have a lot, the ferritin blocks the intestine from absorbing more iron because too much iron in the body is not good. It actually can do a lot of damage. So that mucosal block is helpful in helping prevent iron toxicity within the body. So that's in the small intestine. We have another type of protein that binds up iron, and that's called transferrin. And you can remember transferrin is the form of iron binding protein that transports all throughout the body. I put in red here, it needs copper. I'm just going to make the point now and a couple of times during this lecture that a lot of these minerals work together, and sometimes if you have a depletion in one, it can impact the other. So in this case, iron and copper, or iron needs copper. Absorption and storage of iron is very tightly regulated in the body because the body has limited ability to excrete absorbed iron. As I said, women excrete it every month through their menstrual cycle, but most people don't bleed out on a common, um, you know, on a regular basis. And when you can't get rid of something, it can sometimes build up, and especially if it's a more harmful or toxic micronutrient, that can be a problem. For iron, it is, and so absorption and storage are tightly regulated. Our body kind of likes just to keep reusing the iron. It can get recycled mostly through the liver, and we only excrete about 10% of the iron we take in. It's all part of how we regulate it. I can't remember where I got this picture. I don't think it's from your book, but I just kind of want to review a little bit. You should recognize what this is. We always draw intestinal cells with the little villi. So think about your small intestine and enterocyte that's very good at absorbing. Here's iron floating around. Maybe you just had some food that had iron in it, or you took a supplement. Know that non-heme iron, so something that doesn't come from animals, has to be in the Fe iron +2 form to be absorbed. That's why having iron, non-heme iron with a vitamin C source helps it get into that +2 form. It's going to be absorbed through these intestinal cells better. Here's that ferritin I was talking about. So that intracellular binding protein, you can see that it's, if the green box here is the ferritin, it's storing that iron, and it's just going to keep it there in case your body does need iron. There's a shortage of it, but this is also where it's acting as a block. So if you've got a lot of ferritin and it's starting to build up in these enterocytes, um, iron's not going to be further absorbed. It's just going to stay out here and hopefully be able to be excreted. If iron is needed throughout the body, it does get absorbed through. It doesn't just get to travel around by itself. It's going to bind to transferrin, that binding protein. And again, just like you can measure ferritin to measure your iron storage, you can also measure transferrin in the form of a blood test to figure out someone's iron status. People will also use, of course, hemoglobin and something called hematocrit. If you think about what transferrin is doing, transferrin, one of the ways it gets recycled, it brings it back to the liver. The liver can repackage it and use it and send it back along its way. Transferrin will take iron to muscle. where it's used as part of myoglobin. Transferrin will take iron to bone marrow and also to your red blood cells, where iron is a part of hemoglobin. This is a table from your book. Iron is one of those trace minerals that its absorption is tightly regulated, and a lot of different things impact it. So things that increase absorption, so make it more likely that those intestinal cells can capture and absorb the iron and get it into your blood system. Um, if your body needs iron, if there's a high demand, maybe you've lost blood, we need more iron at higher altitudes. If we're physical training, exercising a lot, or we're pregnant, we will absorb iron more efficiently than without being in those conditions. Similar line of thought, if you have low storage of iron, so you don't have a lot of ferritin, you will absorb iron better. You absorb iron better from heme iron or animal iron. If you have iron with meat, even if it's in the non-heme form, but you consume it with meat, the meat protein factor basically means that you will absorb that iron better because the meat is there. Vitamin C gets iron into that Fe+2 form that makes it easier to absorb. And the more acidic your stomach is, the better you absorb it because it's able to, the body can get the iron from the food easier in a high acid environment. You don't absorb iron as well if you don't need it, if you've already stored a lot. Some things interfere with iron absorption. One of those things is something called phytic acid that we find in whole grains and legumes. Oxalic acid is in leafy vegetables that also interferes. Polyphenols in tea, coffee, red wine, and oregano. If you don't have good stomach acid, or if you're taking in a lot of other minerals that will compete for absorption, and those include zinc, manganese, and calcium. So a little bit about the functions. It is a very important mineral. It's a part of proteins. So we've mentioned hemoglobin and myoglobin already. Those are very important proteins that help carry oxygen throughout the body and to the muscles and the heart. Um, Here's supposed to show a kind of a picture of hemoglobin. You kind of remember thinking about the 3D structure of proteins. Hemoglobin has these four sort of protein blobs, and there's a molecule of iron in the middle of each one of those in part of its quaternary structure. And this is having the iron there allows oxygen to bind. So that's why it's delivering oxygen. Iron's also a component of enzymes and can act as a coenzyme. We need iron in the citric acid cycle, so it's needed for energy metabolism or making ATP. It's also needed for drug and alcohol metabolism in the liver. We use iron to make or synthesize neurotransmitters, and it's also important for a strong immune system. The deficiency disease has a very simple name, iron deficiency anemia, and there's quite a few groups that are at risk for this. Premature infants are babies who are born early. During pregnancy, the ideally the fetus is building up in iron, and so when they're born, they're supposed to have a couple months worth of iron already stored in their body. But if they're born early, that hasn't had enough chance to have it happen. So we worry about iron deficiency in preemies. Children are at a little bit higher risk, usually because of dietary reasons. If they're not eating a lot of meat, a lot of kids would rather, they might getting a lot of nutrition from milk, especially if they're on the younger side, or um, they're also growing. So relative to their body size, they need a good iron source. Females of childbearing age, just because they're losing blood every month through menstruation, and vegetarians because they're not eating heme iron, which is better absorbed. And when you think about iron deficiency, you don't just wake up one day and become iron deficiency. It is something that happens over time or in stages. And I always like to make this point because You start to often feel iron deficiency in the later phases, and at this point, it's always treatable. If it's really bad, you can have a blood transfusion, but it's much better to detect it in the early phases or, of course, prevent it altogether. But even in marginal or early iron deficiency, you might not have any symptoms. You might not feel any different or have any reason to notice it. This again tends to happen most often in these high risk groups. Um, if they don't eat a lot of meat, or maybe their periods are really heavy if it's a female. Um, if you were to check the ferritin, the iron stores, they'd be low, but that doesn't result in any sort of signs and symptoms when your ferritin's low. You'd have more transferrin receptors, so that transferrin's trying to grab up all the iron it can in order to transfer it. But often it kind of goes undetected. When you get into moderate iron deficiency, um, your stores will be very low, so very low ferritin. You might start to notice that you have a decreased work or exercise capacity, so you're starting to feel a little bit more tired. Maybe your immune function's not as strong. You're getting sick more easily, and your body's not able to transport that iron very well, although you wouldn't necessarily feel that aspect. You'd feel the lack of oxygen. That's why you'd be feeling tired. Here's where you most likely will feel it. But notice the most common blood test to detect iron deficiency anemia is hemoglobin, but a low hemoglobin is not going to show up in the early phases. I actually ran into this. I had low iron in college, and I got my hemoglobin tested, and they're like, "Oh, it's on the low side, but it doesn't look that bad." But in fact, it did get bad, and I'm sure if they would have checked my ferritin or something else, they would have discovered that I was on my way to this more severe iron deficiency anemia. At the time, I was extremely tired. I remember falling asleep in class and falling asleep on buses. I was in track and I was tired. My times were getting worse. I was getting, it seemed like, colds all the time. Um, that's the extent of it. And I did finally get treated with iron supplements. But it can be even more serious than that. In children, it can affect their growth and cognitive development, and it can actually increase your risk of mortality. So it can be a very serious deficiency if not treated. Here's what it's going to look like. So this is what you want your red blood cells to look like, nice and red and normal shaped. Iron deficiency anemia is um, the red blood cells won't be as bright red, so they'll be paler in color. There's not as many. You can notice there's fewer of them, and they're usually a little bit smaller than a normal red blood cell. If you took someone's blood and you spin it down, it does segregate into different forms. The red blood cells will all pack at the bottom. So if you measure that, that's what you're doing when you take someone's hematocrit, and it'll be lower in iron deficiency anemia. There's some clinical signs and symptoms. If you're sitting here listening to me, take a look at your fingernails. People who have iron deficiency usually will notice their nails kind of look a little bit pitted like that. A lot of times your fingernails just don't seem as healthy. You might get bruises really easily and kind of have that dent. There can be more than one reason for that, but that can be a sign of iron deficiency. Usually people will look paler, they won't have as much color, they'll be tired all the time. um, more weakness, maybe like getting out of breath, walking up the stairs when you wouldn't normally do that. Pica is a really odd one. So if you remember, if you knew what pica was, it's the desire to eat non-food items. So people with iron deficiency often want to chew on ice. It's not a dangerous thing. I mean, ice isn't, a dangerous to consume it, of course, it's just frozen water, but it's not really considered a food. So if you kind of have a drive to chew on ice, that actually is a sign of iron deficiency. And I did have that symptom. I remember being at a restaurant and having a glass of water with ice and just crunching on it, like to the point where I was annoying the people I was with. And then I found out later that the reason why I wanted to do that was because of my low iron. You also might feel more lightheaded and more likely to faint when your iron is low. There is a UL, so iron is toxic at high levels. That is 45 milligrams a day. I will say if you have a deficiency, they'll supplement it higher than that, but that's not meant to be kept forever. That's just meant to get your iron back to normal, and then you wouldn't take so much. Iron, it really upsets your stomach. I don't know anyone who's on iron supplements who doesn't have some degree of stomach irritation, ranging from nausea, vomiting, diarrhea. Constipation is actually really, really common when people take a lot of iron. It can interfere with absorption of other minerals. Where do we tend to see this? People who take supplements, of course. This is especially true in kids because a lot of kids' supplements kind of seem like candy, like if they're gummies or those chewable ones shaped like cartoon characters. Sometimes kids take too many because they think it's candy, and that the most dangerous thing that can happen is that they would get too much iron, and that would make them feel very sick. Hematocrit Hemochromatosis is a disease, it's a genetic disorder where you don't get rid of iron, it builds up and starts to cause damage to your liver and your heart. The treatment of that is frequent blood transfusions because they have to get that iron out of there um, so it doesn't build up. So Betsy just got diagnosed with iron deficiency anemia. What would be a good breakfast? So this is a question about absorption. So the first option is iron fortified cereal with milk and coffee. Um, that is, whoops, that's not going to be the best answer because both milk and coffee interfere with absorption of iron. Spinach and cheese omelet, that's also not going to be good. Spinach is non-heme iron, so it doesn't get absorbed as well, and cheese is a dairy product. It's going to further make things worse. Steak and eggs is going to be a good answer. Steak is heme iron. Eggs, while not animal flesh, still comes from an animal, so these are going to be pretty bioavailable sources of animal heme iron. Ham, egg, cheese on whole grain bread with OJ. This is okay. The OJ is that vitamin C source, so you will get the iron from the ham and eggs, but the cheese and the bread will interfere with absorption. So that's why C is the best answer. All right, moving on to zinc. Zinc's kind of interesting. It's actually has a lot of similarities to iron. It also kind of reminds me of B12 because the best source of zinc is um, meat and seafood, but we also get zinc from whole grains. It's not a real common problem in the US. Most of us get plenty in our diet. Um, Absorption, transportation, and excretion is also somewhat regulated like we saw in iron, although not quite as much. We do have a mucosal block, so if you consume a lot of iron or zinc, excuse me, metallothione is a protein that will start to build up and prevent more absorption. We don't really store zinc. It is recycled similar to iron, but we can excrete it easier. We can excrete excess iron in our feces, so it doesn't tend to be as toxic as iron can be. Things that interfere or enhance absorption is somewhat similar to iron. If you don't have a lot, if you have a deficiency or you're not eating a lot, you'll absorb it better. It is absorbed better from animal protein. Um, it can be interfered with, so whole grains. Um, if you don't need zinc because you're already taking a lot, you won't absorb it as well. Um, and it actually competes with iron. So if you have a lot of iron, you won't absorb as much zinc. a very important mineral. It's a part of over 300 different enzymes. You've maybe even heard of the term zinc finger. It's involved in DNA synthesis, immune function, growth, development, heme synthesis, so similar to iron, and it's an antioxidant. I put immune function in red. That's one of the more famous functions. They make a lot of products now that you can take if you feel like you're getting a cold, and they're actually just zinc because we know that it does help strengthen your immune system and help you fight off things like colds. A true deficiency we tend to see in really low income communities, often in other countries. When you have low zinc, you're usually not very hungry. It can impact growth in kids. You lose your sense of taste when you have a zinc deficiency, and your immune system is not as strong. In the United States and North America, if we do see zinc deficiency, it's usually because they aren't absorbing things well. They have some type of digestive disease. People who have renal disease and they're on dialysis, and vegetarians who don't eat meat and fish. Toxicity, there is a UL for it. It's with chronic use, so this isn't going to be just after a couple of doses. Even as little as 50 milligrams might start to upset your stomach. 60 milligrams will start to inhibit copper, and excessive amounts can bring down your good cholesterol. So just to kind of give you a sense of zinc in foods and zinc in supplements, I see a lot of zinc supplements targeted towards men. Zinc is part of how the body makes testosterone, so a lot of these products will kind of, promise um, I don't know, a healthier, more robust male, and it might be used to try and you know say that it will enhance sexual function and things like that. If you buy just zinc by itself like this, it usually has about 50 milligrams, which again is over the UL. You should not take that without talking to your doctor. Oysters are a great source of zinc. My husband always takes oysters when he thinks he's getting a cold because he doesn't like to take um, different types of products, but they are very rich in zinc. I take Zicam when I think I'm getting a cold. Um, they have only 10 milligrams, but I feel like it kind of helps. I'm probably just trying to make myself feel better. And I've used these as well. They're just kind of like throat lozenges that are actually a zinc supplement. They have 14 milligrams. And again, it's just one of those nutrients that if you are coming down with something can help. Okay, copper is kind of a weird one. I don't think we often think about copper in our diet. It's in quite a few foods, including chocolate, so that's always fun. Also, shellfish, nuts, seed, mushrooms, soy products, dark chocolate. We tend to get plenty of our diet. 900 micrograms is a pretty small amount, so we don't need a whole lot. Nothing real remarkable about absorption, transportation, and excretion. We don't really store it. We can excrete it, so it's not um, easily toxic. Just like zinc, it can bind to that protein metallothionein in the intestine and block absorption if we need it to. Um, Copper balance in the body is somewhat regulated, and it is influenced by both iron and zinc. It's kind of a creepy picture. So if you think that that eyeball looks like a penny, it's because this is a person with Wilson's disease. So they overabsorb copper and they have trouble getting rid of it. And so the copper will actually build up in the body so much so that you'll actually see it in the eyeball. So that's exactly what you're seeing is copper buildup. That is not good. Um, Wilson's disease is a disease that causes you to do that. Um, I actually don't know the treatment for that. I'm guessing it might be a blood transfusion as well. But we need copper. It's part of iron metabolism. It can also act as an antioxidant. Menkes disease is the deficiency disease. It's extremely uncommon. I've certainly never run into it in any of my personal or career, so not common. Is chocolate good for you? You might have heard that it is. You probably have a sense of which one of these types is the best. So we've got dark chocolate, milk chocolate, and white chocolate. Dark chocolate, which is a high percentage of chocolate and not as much sugar, is an antioxidant. It does have some nutrients like copper in it. These types of chocolate are definitely more processed. They tend to be more fat and sugar and not have a lot of the cocoa in it that gives you its more health qualities. But a little bit of dark chocolate, not this much, could certainly be part of a healthy diet. So another just sort of pause here and think about some of the things that we've learned. Talked about anemia a couple of times with a couple of different micronutrients. So anemia is anything that is wrong with your blood. So all of these vitamins and minerals, if you have a deficiency, can cause an anemia. And I just want to know if you can match them up. So for vitamin E, you kind of have to go back a little bit. That's that fat soluble vitamin. And a deficiency um, can cause hemolytic anemia. Remember, vitamin E is an antioxidant and it helps keep the lipids safe, especially those in cell membranes. And so if you don't have that good antioxidant in your cell membranes, your cells can burst and cause excessive bleeding, especially for your red blood cells. Folate is a water-soluble B vitamin. It's important for DNA synthesis. So when your folate is low, you can actually get megaloblastic anemia. You get these really large red blood cells because the DNA replication starts, but it isn't able to finish without folate. So it builds up and causes these large blood cells. B12 is the same megaloblastic. That's because B12 is needed for normal folate metabolism. Iron, I don't know if I said this explicitly, but iron is microcytic. That's when you get those small, sort of pale looking red blood cells because your iron is low. And copper would also be microcytic. That is because iron needs copper. So if your copper is low, your iron's going to be impacted as well. Who knew, right? That all these things were important for healthy blood. All right, manganese is kind of a weird one. People don't really talk about it. That's because it's not a very common deficiency. It's in whole grain cereals, nuts, legumes, and tea. We don't know a whole lot about it. There's no functional marker. We don't absorb a whole lot of it. We do absorb it better if iron status is good. So it's kind of another example of how some of these minerals help each other out and sometimes compete with each other for absorption. In terms of its function, it's very similar to zinc and copper. It's a cofactor for enzymes and involved in energy metabolism. Again, deficiency is rare. The toxicity is a really weird one. So people don't usually take these in supplements. The toxicity is actually because you get exposed to manganese when you inhale a lot of car emissions. So sort of maybe a high pollution area or maybe some careers if you were working in a garage and inhaling car emissions all day. And it's toxic because it can cause nerve damage. Iodine, I always find kind of interesting. You've probably, if you've ever noticed salt, if you've purchased it at the store, we'll say iodized salt. So iodine is found naturally in salt water, seafood, and seaweed. If you don't eat a lot of those products, you have to get it through iodized salt. It's also found in molasses and dairy products. Um, So the RDA is only 150 micrograms. In the United States, it's required that our salt have iodine added to it, and we eat a lot of salt here. So we do not see iodine deficiency in the United States because of this fortification of salt. Um, we absorb it very efficiently, so it's very easy for us to absorb it. We actually store it in our thyroid gland, and that's because your thyroid gland uses the iodine, and we excrete it in the urine, so it doesn't build up and get toxic very easily. Iodine has one function, and it's all about the thyroid hormone. So here's your thyroid hormone. It's found in your neck. And you probably have heard of that it's important for metabolism. So what happens if you have a iodine deficiency, you get this, which is kind of a creepy picture, but this is a woman with a goiter, and it's because her thyroid gland kept getting bigger and bigger and bigger. So because your thyroid needs iodine, if there's no iodine, it gets bigger and trying to capture any iodine it can find. So that's why you find those large necks. So a goiter is technically what we see in an adult who has iodine deficiency. Uh, cretinism is what we tend to see if a child has iodine deficiency. They will have poor growth, and it also impacts their cognitive function, sometimes very severely. Here's where we see iodine deficiency. I just kind of give you a global snapshot. And so the places in purple are the problems area. The darker the purple, the more severe. And what these countries have in common is that they don't add iodine to their salt. So they would have to rely on usually seafood or seaweed. And if that isn't available or people aren't eating it, you will start to see goiters and problems with iodine. There is a UL. You can actually have too much, and it will make your thyroid gland get bigger and increases your risk of thyroid cancer. We tend to see this in Japan just because they eat a lot of seaweed. Seaweed is part of their sort of normal dietary practices. Chile happens to have a lot of iodine in their soil, so all the food they grow there um, can sometimes cause people to go over the UL. Selenium is a mineral found in seafood, meat, cereal, grains, and nuts. We get selenium from the soil. So if you grow, for example, wheat, if there's a lot of selenium in the soil, your wheat will have more selenium in it. It doesn't tend to be a problem nutrient. We usually have above the RDA. No major issues with absorption, and excess can be excreted in the urine, so it's not terribly toxic. In terms of function, it's a good antioxidant. It's very similar to vitamin E in that regard. It can protect our cell membranes from oxidation. We also use it to synthesize thyroid hormone, and it may decrease the risk of cancer, especially prostate and lung. There's no specific deficiency disease, but if you're low in selenium, it can cause a type of heart issue called Cushing's disease. There is a UL. This is usually from supplements. They could cause kind of stomach problems, hair loss, and change in your nails and skin rashes. Selenium was, I used to hear more about it. Epidemiology studies, those are those kind of larger scale studies that they do over time, were showing that where selenium levels were show that where selenium levels in the soil are high, death rates from cancer are lower. So the idea was that selenium is good and maybe it's helped preventing cancer. So they actually started doing clinical trials where they were giving men supplements, and they were looking at a couple different things, selenium, vitamin E, or a combination, especially in with regard to prostate cancer. But that study, like many of these, found that when you supplement, it really doesn't seem to be doing anything. So they actually stopped the trial. Um, so that happens a lot where, when things in diet do not equal taking the supplement. Chromium, we're getting here towards the end. We don't have great nutrient databases about chromium, so we don't know chromium content in food very well. We do know that it's found in a lot of different foods, including broccoli, processed meats, liver, eggs, and whole grains. It's not a common deficiency, so people don't tend to have problems with it. It's not toxic. It's gotten a little bit of press because it may help improve insulin function and help normalize blood sugar. So sometimes people with diabetes will take chromium supplements, but there hasn't been a lot of good research to show that that's actually beneficial. Fluoride, you probably never thought of as a mineral, it's just something that's in your toothpaste and water. We do fluoridate our water in quite a few places in the United States, and certainly most of our toothpaste also has it. We absorb it easily. We store it in our teeth and bones, and that's actually why we need fluoride. It's a part of our teeth and our bones, and its function is to promote good bone and dental health. If you have a deficiency, you have a higher risk of cavities or dental caries. What I'm showing you here actually is what happens when you have above the UL. We tend to see this in children because if they're not properly supervised, they swallow the toothpaste. And when they have a lot of fluoride, you start to get these spots on your teeth called mottling or fluorosis. It's not dangerous, it just kind of makes your teeth ugly. People have said all kinds of weird things about fluoride. Some questions I've been asked: if you drink bottled water, will you still get fluoride? Probably not. It depends on if the people who bottled the water, where they're getting it from, and if they're adding anything. But sometimes that can be bad. If you only drink bottled water, you might be missing out on fluoride. Do you even need fluoride? If you brush your teeth, isn't that enough? Actually, you need to both consume and put the fluoride directly on your teeth with toothpaste for optimal dental health. Are there other health effects of too much fluoride? Some people think that it's bad and that it might cause bone cancer. There's no evidence of that whatsoever. So as far as we know, it might spot your teeth, but that's the only toxicity. Ultra trace minerals, I'm not going to spend a lot of time on. They're ultra trace because you need them in such tiny, tiny, tiny amounts, but they do still have some functions in the human body. They are considered minerals, just needed in small amounts. You can see the list here. Again, I'm not going to go into a lot of detail about them, but if you ever saw them, you could sort of recognize them as a mineral. We're going to end this lecture talking about vitamin-like compounds. These are conditionally essential, meaning that usually your body makes them, but under certain conditions, you might need to take a supplement or have them in higher amounts. So they all have in common your body can synthesize them. They're also found in foods. Usually the condition is rapid growth and some diseases. A lot of these are found in infant formulas because that's a period of rapid growth. Carnitine is a supplement that sometimes people take because they think it will help with weight loss. It's made from the two amino acids lysine and methionine, and we find it in meat and dairy products. It has one important function. It helps bring fatty acids from the cytosol to the mitochondria, and this allows for energy metabolism and the creation of ATP. The supplements presumably, they usually promise that you'll burn more fat, although research has not shown that that actually does that. Um, People can be born with carnitine transporter deficiency. It's a genetic disease. It's very serious and dangerous. It has all of these problems associated with it. People with carnitine transporter deficiency have to take carnitine supplements. They have to make sure they're getting food on a regular basis, and they have to be careful with their diet. Again, and also to make sure they get enough carnitine. Taurine, you might have seen in energy drinks. It's also made from two amino acids, methionine and cysteine. Um, we usually use amino acids to build protein. Taurine does not do that. It's not part of building up muscle because it doesn't link with other amino acids and polypeptides, which are just amino acid chains. We actually mostly use taurine as an antioxidant, and a little bit of research, not very conclusive, um, said it might improve mental and athletic performance. Um, it's recommended to keep intake under 3,000 milligrams, but it's not an essential nutrient, so we don't have specific recommendations about it. I'm putting here different places where you might see it. You can buy it as a supplement. They often add it to infant formula and energy drinks. We find it in these meat products. This is kind of a weird picture. I put this here because cats need taurine. It's actually an essential nutrient for them, and if they don't get it, it actually can cause blindness. But we are not cats. So how should you get your vitamins and minerals? Food is definitely the best way. If you eat a wide variety of foods, including fruits, vegetables, whole grains, and dairy, you should probably be all set. Taking a vitamin doesn't make you a healthier person and can't substitute for healthy eating, and cannot provide all of the missing substances of a healthy diet, and it's easy to overconsume when you take too much of certain supplements. Having said that, they exist for a reason. There's definitely people who might need a supplement. Some examples of people who often need supplements are pregnant and lactating women, older people, strict vegetarians, people with food allergies, and people with certain medical conditions, especially if it affects their ability to absorb nutrients. You've probably seen some of these lists where they talk about superfoods and why they might be good for certain conditions or disease states or just for general health. And this is kind of getting into, eating a variety of foods and kind of thinking about food as medicine. Certainly, when you do eat a lot of different foods, especially if they're healthy foods, that can improve your health and might be, if carefully planned, probably provides better nutrition and health than taking a supplement. They make a lot of fortified foods now, so they'll add vitamins and minerals and other things to a whole variety of products. Waters, cereals, Oreo cookies, kind of granola bars, and even eggs have fortified nutrients in them. Um, Sometimes these can be really helpful to get more of certain nutrients. A lot of times, they're not helpful. They kind of trick people into thinking it's a healthy product when in fact it's just an Oreo cookie with some vitamins added to it. So you really kind of have to be a smart consumer to sort out which one of these is useful and which um, is sort of meaningless because it's really not a healthy food at all. Thinking about which supplement to take if you're interested or think you might need one. I often recommend Nature Made. They do go through a voluntary sort of process to make sure that it's a more safe product. A daily multivitamin doesn't have huge mega amounts, so it's less likely to cause a toxicity. I always worry about gummies, especially for kids. Again, you have to be careful because they seem a lot like candy, and sometimes kids will get into them and eat too many, which can be very dangerous. So how do you pick a supplement? I've said this before, but remember that they're not very regulated. The Food and Drug Administration has sort of loose oversight, but really only steps in if something is shown to be harmful. So you should always talk to a medical professional, either a dietitian or maybe a doctor, and you should certainly let them know if you're taking anything. Things to look for, you don't want more than 100% of any single nutrient. USP is that certification I'm talking about that Nature Made goes through, that does make sure that they've um, have gone through some type of regulation. Again, make sure you're not going over the toxic amounts and make sure they're not putting in unnecessary things that you don't need or you don't even know what they are. They make a lot of specialty supplements now. Some of these I think are very useful, some of them maybe not so much. Prenatal vitamins are very useful and always recommended for a woman planning a pregnancy and who is pregnant. She will have a lot more nutrition needs than a non-pregnant woman, and those can be really, really helpful to have a healthy pregnancy. Um, this one I was talking about was the zinc, the sexual energy. This probably has more zinc than it needs. Usually we just kind of need the standard one a day. It is good to get the gender specific one. Men and women do have different vitamin and mineral needs, so that's always a good idea. The kid ones you rarely need. They make them for eyes and hearts and digestion and all that. Those, for the most part, have not been well researched, so you probably don't need those. They do make vitamins for elderly. Those can be useful because they often will have higher nutrients that are specific for the recommendations for an older person. So we're going to end this just kind of testing our knowledge. One of the things you'll have to be able to recognize very quickly is if a vitamin is water or fat soluble. So in this case, fat, water, water, fat, water. The least active form of vitamin A in the body, that's going to be the carotenoid. Remember, those aren't as active as the preformed vitamin A sources. Vitamin D is all of these, all of the above. You want to add more vitamin E. What could you do? The answer is all of the above. What is considered an antioxidant? Only vitamin E on this multiple choice. This is just kind of a way to summarize data. We kind of go through these one by one and they start to jumble together. But this is listing the vitamins and minerals by their function and what they're good at. So that's kind of a nice summary slide that would be useful for studying. And they do a lot of things in the body. So we actually have 2 full slides of that. And we're going to end thinking about organic. It doesn't totally fit here, but I find students often have a lot of questions about it. So thinking about what does organic mean? Are organic foods safer? Are organic foods healthier? And the dirty dozen is a kind of a good concept to understand. So when you see USDA organic, you do know that that has gone through a regulatory process. You can't just put that on there. The USDA has to inspect and improve, so to make sure you can put that label on. And organic really refers to um, way things are grown or how animals are treated and fed. So it's no chemical-based pesticides, no synthetic fertilizers, no irradiation, and no bioengineering, including genetically modified. There's other terms out there um, that seem like they might be organic but have a different meaning. So USDA certified, free range, kosher, natural, no hormones, no antibiotics. Um, you know, that doesn't mean something's organic. I'm not saying any of these are good or bad. I'm just saying that organic means a very specific thing. We have different levels of organic. This is actually from another textbook, but 100% organic, I think it's pretty obvious what that means. If it just says organic, it has to be at least 95%. If it says made with organic, it has to be at least 70% organic. Anything else, you can assume that it's less than 70% organic. Are they healthier? That's not as clear cut as you might think. Sometimes they're healthier. The nutrients and phytochemicals can get more condensed, so have a higher quantity just because you can't use like unnatural pesticides and things like that. So the fruit or vegetable can have more natural defenses, which is usually a good thing. Conventional plants, if you've ever noticed, tend to be a lot bigger. The organic tend to be smaller, so again, there's more nutrient density in the smaller organic version. Organic is definitely more expensive a lot of times. If you can't afford it, you can still eat produce. You know, if you buy local in season, frozen and canned, those can be very healthy and less expensive choices. Fresh produce, if you wash it carefully, you can really get off most of the, you know, things like pesticides that you might have been worried about um, on the conventionally grown. This is a good way to think about reducing pesticides, you know, using these vegetable brushes, peeling the outer layer on where most of the pesticides would be, and also just eating a variety of foods. They tend to use the same pesticides on the same products. So if you eat a wide variety, you're never going to get like too much of a certain one. This is the Dirty Dozen. Are some things better to buy organic than others? So these are fruits and vegetables that tend to be higher in pesticides, and that's usually because they're more difficult to grow. If you think about these, they don't tend to have natural defenses, meaning that pests can get in and get at them really easily. Where these foods that tend to be cleaner, like an eggplant, right? You don't eat the outside, you peel it. It kind of has that natural defense, so it's harder for pests to get at it. So usually anything with kind of a outer shell that we don't eat tends to be cleaner because it requires fewer pesticides to grow. Anything a little bit more delicate that doesn't, you know, where you eat the outside, it's hard to peel. Those often require more pesticides and therefore would be dirtier. So just to make sure you understood that, which one of these would you buy? Organic, probably the strawberries, right? Because when you peel the apple and you peel the orange, you're removing a lot of the, if there was a lot of pesticides used, you're not eating that part, so a little bit cleaner. And that is the end of micronutrients.